Welcome again in the class of Ved Prakash Saraswat. I am with some concept of class 10. In previous class, I was discussing about the refraction of light through a lens. I have told you that what are the basic incident rays by which we can draw the ray diagrams easily. So I have told you the three rays. One was coming parallel to the principal axis, one was coming through focus, and one ray which was coming through the origin. I have told you how the rays behave when it passed through the lens. So with the help of these rays, we will draw the all possible ray diagrams when the light passed through a convex lens. Okay, so to draw the ray diagrams, first we should recall the basic concept of a convex lens. This is convex lens, this is origin, this is F, this is 2F, this is F dash, and this is 2F dash. Possible conditions. First condition, when object is situated at infinite. Number 1. Number 2, object is beyond 2F. Number 3, object is at 2F. Number 4, object is between F and 2F. And number 5, object is at F. And number 6, object is between F and this origin. These are 6 possible conditions where the object can be kept. Wherever you are putting the object in the front of lens, all positions will be covered in these 6 positions. Now, we have to start to draw a diagram. First, I will take first one. When object is at infinite. So when let the object is at infinite, let one ray diagram we are drawing. One ray which is coming parallel to principal axis. One more light ray which is coming parallel to principal axis. As we have discussed, the light rays, those comes parallel to principal axis. These meets at F dash after refraction. So these light rays will meet at F. So this is the image of the object. Now we must know about the nature of image. Number 1, point size. Number 2, this is inverted. At F dash. These are some possible you can say characteristics of or nature or characteristics of the image which is formed when the object is at infinite. Okay. In this case, now so this condition is over. Now let object is beyond 2F. Beyond 2F means object is situated somewhere beyond 2F. Let object is kept at this point. This is object side, that is point A, and this is B. So I will take first light ray which is coming parallel to principal axis. Again, as per condition, this light ray will pass through focus after refraction. Please recall the memory. I had told you from where the light ray will pass. The light will coming from infinite, from the source of light. It is passing through the object, coming parallel to principal axis. After refraction through lens, it will pass through focus. Let I am taking one more light ray. Let I am taking one more light ray which is coming through focus. You can take any two light rays. I told you that one light ray which comes through focus, it always go parallel to principal axis. So it will go like this after refraction. Okay, so this is the point where the refracted light rays those goes from the lens meet. So this point, this one, this is image. So now we have to go through the characteristics of image. Number one, real. When real image is formed, when refracted light rays actually intersect each other. So real image, because this opposite side, so inverted. Number three, between f and 2f, f dash and 2f dash. Real inverted between f dash and 2f dash, and size is smaller than object. Okay, now second condition is over. Now let's come on third. Third condition again now. This is principal axis. This convex lens. This is f. This is 2f. This is f dash, and this is 2f dash. So object is at 2f. Now again I will take one light ray which is coming parallel to principal axis. One light ray which was coming parallel to principal axis, it will pass through focus. Okay, I will take one more light ray. Let it is passing through O. We can take any two light rays, either which is passing through F or O. That I am taking the light ray which is passing through O. So this is the light ray which is passing through O. So it will not deviate from its path. It will go straight. I had told you earlier also. So in this case, the image will form at 2f. So characteristics of the image. Number one, image will be at 2f dash, real, inverted, and same size of object. This is now condition number 3. Let's come on condition number 4. object is between F and 2F. Okay, this is the lens. This is F. This is 2F. And object is kept here somewhere. Again, one light ray which is coming parallel to principal axis, I will take it. It will pass through F dash, and one more light ray which is going through F dash, this F, that will go parallel. So this is now at this is 2F dash. So its image will be beyond 2F dash. Image will be now characteristics. Image will be beyond 2F dash. Okay. Image will be beyond 2F, larger than object real, and number 4 inverted. These are characteristics of image when object was between F and 2F. So this is also what. Now, new condition when object is at 2F. When object is at 2F, so now this is principal axis. Now lens, this is F, this is 2F. Object is kept at F. So first light ray which will come parallel to principal axis will pass through focus, and one more light ray which is coming through O, it will go undeviated. Are you seeing both light rays are going parallel to each other? So these both light rays are going parallel to each other. In that case, these will meet at infinite. This is very good question. When the two light rays go parallel to each other, how these can meet? Question of mathematics. I will discuss about it later. Okay, but at this time you should know how when the light rays go parallel to each other, then these meets at infinite. So characteristics of image, number 1, image will be at infinite, the sign of infinite. Number 2, real. Number 3, highly enlarged. Highly enlarged and inverted. Inverted. This is formation of image. So it was the image when the object was kept at F. Now last point, when object is between F and O. Okay, last point, when object is kept between F and O. F and O. Now this is convex lens, this is O, this is F, this is 2F, this is F dash, this is 2F dash. Now that object is kept at this point. First light ray, it will come parallel to principal axis. It will go through F dash. One more light ray which is going through O. it will go undamaged. So, I am observing the gap between these two light rays is increasing continuously as and when the light rays are going away from each other. So, at distance is more, in that case, the gap between these two refracted light rays will increase. But when we extend these two light rays in backward direction, these two light rays will intersect each other. So, image will be formed here. Now, a special type of image. This image is not formed because of the intersection of refracted light rays. This is made by the intersection of image of refracted light rays. So, the image will be virtual. Number 2, erect. Virtual, erect. Number 3, highly enlarged. Same side of object. Virtual, erect, highly enlarged, and same side of object. Okay, so this is the characteristics of the image when object was kept between F and O. Now these were the ray diagrams when object was kept in the front of a convex lens. Now we will discuss the ray diagrams when object is kept in the front of a concave lens. Okay. Now image formation. When object is kept in front of concave lens. For the image formation, when object is kept in the front of concave lens, we are having only two conditions. When condition number 1, when object is kept at infinite, and condition number 2, when object is kept anywhere between infinite and origin or O. So let's see how the light rays behave when we pass through concave lens. So condition number 1, when object is at infinite, so this is now principal axis. Now this is the diagram of concave lens. This is O. Now this is F. This is 2F. This is not only F, this is F dash, and this is 2F dash. So it will be your F. I have discussed about these F or F dash or 2F dash. I hope you have understood why I am giving the name as F dash, 2F dash. This is F and 2F. In case of convex lens, I had written here F and 2F, and this is F dash and 2F dash. Please recall memory. Now, when object is kept anywhere in the front of concave lens, in this case, the light rays will diverge. They will not converge. So, when the light will pass through this lens, it will go away from each other, and they will never intersect each other. So, when we extend the light rays in the backward direction, the light rays will meet at one point. this is F dash. So the formation of image will be as at F dash, image is not real, this is virtual. Now erect and at F dash, at F dash. This is the ray diagram of object. This is the ray diagram when light ray will coming from infinite, reaching at the surface of the concave lens, and you are diverging from the lens, and this is characteristics of the image. Now condition number 2, when object is anywhere between infinite and origin. Okay. So the image will be as, again this is concave lens, O, F dash, this is 2F dash, this is F and 2F. Let I have kept the object here. So first light ray which will go parallel to the principal axis, it will diverge direction. Okay, so it will come back from F. Let I am taking one more light ray which is passing through O. So it will not come back, it will go direct, straight. So the both light rays are intersecting each other at this point. So image formation, how the characteristics of the image. Now number 1, image is virtual. Number 2, erect. Number 3, smaller in size than object. And between O and F dash, same side of object. Okay, these are the characteristics of the image formed when object is kept in the front of a concave lens. So I hope you have understood these. Now in the next meeting we will wind up this topic of light. So I will give you some questions also. I will put some photograph of the questions. Please try to solve those questions. Thank you.